So table one, what did we notice or wonder about either of these tables? Okay, so the X's or the inputs are the same for both. Table two, give me another wonder or a notice or a wonder, it's fine. There's fractions in the Y's. If converting it to a decimal makes it easier for you to tell what's going on, you could try that. But yeah, there's fractions in the outputs. Question, Karen? If you can give me another notice or wonder, then yes. Both of the Y's start with 2. All right, but yes, they both actually start with the same coordinate. Can someone tell me what type of feature that is on the graph? I don't want to give it away yet. Well, they are functions. They are both functions. That is a good notice, Harley. So good. What I just circled right here is your y-intercepts. How do you know it's a y-intercept? Harley?
That's like where the start is.
That's where the start of the line is, usually anyway. But also by definition, y-intercept is when x is 0. So if you have the x is 0, then you have the y-intercept on your table. So good. Any other notices? I'll take a volunteer now. Any notices, any patterns that are going on in either table? Willie? Okay, you notice that in the table. Table of values. Identifying patterns in table of values is a really big skill this semester. We're going to do it all the time. Can we tell based on the table, like table A, what type of function this would be? So anyone. Based on the pattern in table A, what type of function is it? Or can you tell me what the pattern is? Table 8. Okay, wait, you listening real quick? Okay. Tell me one way that I could go from 2 to 3.5. What could I do?
1.5.
You could add 1.5, right? See if that continues throughout. So that's a good way to be able to find a pattern. See if what you do to one set of outputs can be done to get the rest of them. So like, notice that. Could I also add 1.5 to 3.5 to get 5? Can I do 5 plus 1.5 to get 6.5? And 6.5 plus 1.5 to get 8? So that's a pattern. I'm adding the same amount each time to the y's to get the next y. When I have to add the same amount each time, what type of function is that? We've only learned a few of them, so. So when I add or subtract the same amount each time, that follows what type of function? If I graph this, what would it look like? Say it loud and proud, I can't hear. Little whispers out of them. Linear, thank you. There's only a few that we've ever talked about in here. Linear is like one of the few you guys can tell me about from like your middle school age. So like that, I would probably write down. Everything that I write, you should probably write down. But table A is linear because we're adding the same amount each time, same rate of change throughout. If I graph it, it'll look like a straight line. Now, can we figure out the pattern in table B? So like table 9, what's one way that I could go from 2 to 3? You could try adding 1. Now see if that's consistent throughout class. Is 3 plus 1 9/2? Right, no, so that must not be the pattern. Is there another way I could go from 2 to 3? Or from 3 to 9/2, or from 9/2 to 27/4? All right, talk about that in your groups. See if there's any way you can think of to go from here to here, or here to here, and then see if it's consistent throughout. I'll give you like a minute or so to try and figure it out with your groups. If someone's quizzing, don't include them. Okay.
There is no pattern.
Okay, Jack, what'd you get?
I'll spot by 3.
Sorry.
My 3.
Just by 3?
Yeah.
So 2 times 3 is 3?
Bro, what are you talking about?
But we're getting close. You might have looked at what can I multiply by 3 to get 9/2? You can multiply by 3 to get 9, but how can I have that 2 still be a part of it? Anyone else?
Is he right?
Not fully right. If I'm multiplying to get a fraction, maybe what I'm multiplying by
Oh,
is a
by-
fraction.
Yeah, you.
Okay,
3 times 3.
okay, good. So like from here to here, I multiplied by 3/2 to get the next one. See if that pattern works for all the outputs. Like is 2 times 3/2 3? Do you guys know how to check things in your calculator also? I know fractions aren't probably your favorite, but they're really not that hard. And if they are that hard for you, use a calculator. So C, if you are using a calculator for this, I do recommend that fractions go in parentheses, like this. But yeah, 2 times 3/2 is 3, so that works there. What about 9/2 times 3/2? If you want to see if it equals 27/4 and it gives you a decimal, press the fraction to decimal button. Almost all calculators have it. I'd say probably not your iPhone calculator, but yeah, it is 27/4. See if it continues throughout. 27/4 does give you 81/8 when you times it by 3 3/2. So that is the pattern. I know it might not be easy to see all the time. Probably in the next few lessons, I'll give you a really easy way to find it. But for right now, you should just try to see if you can figure out the patterns and see if it's consistent throughout. What's it called when you multiply each time to get to the next number? What type of functions are those? No, that would be adding each time. There's only one other type of function I've taught you, and it happens to be the name of this unit. Maybe look around the room, look at your objective, look at like the titles of the lessons that are on the whiteboard. Not decay. Other words around the room. Check the learning goal on the back. So not decay, but what's the other word? Okay, exponential. I know we're still in the earlier stages of the unit, so it's fine that you don't know that like by heart right now, but you need to start knowing that. Put it on a flashcard. I don't know, but you'll see it in geometry, algebra 3-4, so it's better that you just understand it now. When you have to multiply each time to get to the next number, that's an exponential function. Would you say that the numbers are increasing or decreasing? Increasing, so this would be exponential growth. Today, we're going to talk about exponential decay. But good warm up. Any questions before we move on? All right, so key things. If you add or subtract each time, that's linear. If you multiply or divide, it looks like you're dividing sometimes, then it's exponential. All right, but here's the learning goal today. See if I have it in this one, no. Okay, but anyway, it's always on the whiteboard in case principals come in and ask you what you're doing today. Look at the back whiteboard and it's there. Okay, side conversations, wait till later. But today we're looking at exponential decay. The learning targets are on your paper. By the end of the lesson, you should be able to do all of these things. Be able to use only multiplication, because that would describe our exponential functions, but only multiplication to represent decreasing a quantity by a fraction of itself. Writing an expression or an equation to represent a quantity that decays exponentially and knowing the difference between exponential growth and exponential decay. I'm recording right now, like always. Should you ever need to work ahead for whatever reason, I have it linked in the slides as well from last year. Puzzle piece is lesson 4. And your next quiz will be Monday. So not this week at all. Just Monday, be ready to go through what we covered Friday and for the rest of the week. So even if you're absent, you still take the same quizzes and tests as everyone else. So make sure that we are staying up to date. Our notes are staying up to date, so you can use them on those quizzes. Questions on any of that? Okay. So follow along. The first one's just an example. Diego has $100 and spends 1/4 of it. How much does he have left? So think about that mentally. Don't say it out loud. Think about it. $100 spends 1/4 of it. How much does he have left? Now we can say it.
$75.
$75. $100 is a really easy number to work with, right? Split it into fourths, 25 each. He has 75 left if he only spends 1/4 of it. Not all the time are the numbers that easy, but here's one way to think about how much Diego has left after spending 1/4 of 100. You need to be able to explain each step. So even though you might have done it differently in your head or on a calculator, here's one way that will help you kind of set up the rest of them. So 100 minus 1/4 times 100. What's 1/4 times 100? What's 1/4 of 100? 25 is 1/4 of 100. Doesn't 100 minus 25 also give you 75? Yeah. And that's what happens here. But, or that's probably what you did in your head to get the answer. But notice the difference here. They're doing 1 minus 1/4. What's 1 minus 1/4?
Yeah.
No. That would be 1 minus 1.
Oh, 3/4.
Okay, good. Instead, they times it by 3/4. What's 100 times 3/4? Do we know how to use calculators to check? Or if we can't do that mental math? So every time you put a fraction in a calculator, highly recommend you use parentheses. But look, it also gives me 75. What way do you think is easier? Do you think it's easier to do 100 times 1/4 and then subtract it from 100? Or do you think it's easier to just times it by 3/4, which is what remains?
Yeah. Or,
It's up to you. That's more of an opinion question. But doesn't it give you the same answer? So I've always, like, if I was at a store and I was trying to figure out what the sale is, so say it's like 20% off. When I would try to figure out what it costs, I would do 100 or whatever it costs. The original price times 0.2, subtract it from the original price, and that's what I would pay. After this lesson, teaching it, I realized it'd be a lot easier to just multiply it by what remains. And that's just one step I'm having to do in the calculator. So this really did help me in the real world, like save myself some time. It could help you not only with this lesson, but also in those situations as well. So using that logic, which still gives you the same answer of 75, in your groups, you're going to answer number 2 and 3. A person makes $1,800 per month, but a third of that amount goes to her rent. What two numbers can I multiply to find out how much she has after paying her rent? And then differently, different situation, write an expression that only uses multiplication, and that's equivalent to x reduced by 1/8 of x. I'll give you about 3 to 4 minutes to have those answers for when you're called on. It said, what two numbers can you multiply to find out how much she has after paying her rent? Did you figure out what those two numbers are? Yeah, that's what this question is asking. I mean, you need this information, but what two numbers can I multiply to find out how much she has after paying her rent? Or, table 4, can you tell me how much she has after paying her rent? Did anyone get a different number for how much she has after paying her rent? Damien?
1,200.
Okay. So we'll come back to table 4. But Damien, can you tell me how you figured out that it's $1,200 she has left?
Like, what do you mean?
How did you know the answer is 1,200?
I divided 1,800 with 3 and I just had 600. I was like, oh, 600, 800, 200.
Okay, so splitting 1,800 into thirds, there's 600 for each third, right? If she's losing only 1/3, right, that's 1,800 minus 600. That does equal 1,200, so that is how much she has left. But was there any multiplication in that situation, like in those steps? No, so while that is the answer, 1,200, the question now is what two numbers can I multiply to find out that same answer? So let's see what table 1 says. Everyone else needs to stop talking. Table 1, what two numbers do you think? And why 2/3? Are you sure 1,800 and 1/3, or do you need? Just how'd you get the 2/3? Why did it change from 1/3 to 2/3? Okay, good. 1 minus 1/3 is 2/3. Is 2/3 times 1,800, 1,200? Test it out in your calculator if you're not sure. $1,800 times 2/3, is that the same as 1,200?
Yeah.
So then the answer to this question is 1,800 and 2/3 are the two numbers I can multiply by to get the same answer. Now you might be asking, why do I care? It'll save you a step. And our exponential functions only have multiplication in them, not necessarily subtraction. So you have to be able to multiply by what remains. So this is what remains after she's paid her rent. That's what I multiply by to get the next answers if I wanted more answers than that. All right, good. Let's see. Table 5. You're gonna help me out with number 3. Write an expression that only uses multiplication and is equivalent to x reduced by 1/8 of x. You have the sign difference. So table 5, tell me this, do you have the answer or do I need to give you a easier question first? Okay, x reduced by, what does that mean in math? Well, 5, isn't it? Subtracting 1/8 of x, which 1/8 of x, you would normally have to do 1/8 times whatever x is. You need to write something equivalent to this that only uses multiplication. So consider like the work we did earlier. If it helps you to put a number in for the x to see if your expression is correct, then by all means. But if it's being reduced by 1/8, how much of it remains? Seven eighths, another table helps you. And 7/8 what? We're missing something else. X. That's it. Doing this math on the left is the same as doing that math on the right. If this helps you further, what's the coefficient if it's not written? 1 minus 1/8 is 7/8, and then since these are like terms, you don't change the like term though. It's still an x. So that answers it. Yes. Well, okay. What's 1 minus 1/8?
7.
Just 7?
7.
7/8. So that's right.
Oh.
So if I'm losing 1/8 of it, what do I have left?
Oh, okay.
So instead of doing 1 or whatever, instead of doing what I had minus 1/8 of what I had, I can just save myself a step and just multiply what remains. Yeah, you guys are gonna be mind blown probably in a few minutes, but for right now, that's the answer. Question so far. Okay, so consider that when we do this next problem. It's really similar to something we had before, where you fill in the table And it starts out pretty easy, you just continue the pattern, but then you have to make the expression. So just remember the math we did earlier to see if it'll help you with this one. But here's the situation. Every year after a new car is purchased, it loses a third of its value. Let's say that a new car costs $18,000. A buyer worries that the car will be worth nothing in 3 years. You agree with that? Yes or no, and why? And then fill out the table. So we'll just start with those two right now. Talk in your groups. Would a car lose all of its value after 3 years and losing a third every year? And then fill out the table if we're following the pattern, however you need to do that. Do you think that the car will be worth nothing in 3 years?
Yes.
Why do you say yes?
Because,
Let them do it.
because I subtracted 6,000 every year, and then by year three, I know statement is there.
Okay, so it looks like we're establishing that a third of 18,000 is 6,000. So you're saying that it loses 6,000 each year? Okay? Anyone disagree with that? Now you guys probably don't have a car yet. So you may not know, but even like really old cars usually still sell for something now. Like I had my first car was a 1999. When I sold it, I still got $2,000 for it. So realistically, a car that's worth $18,000 is not gonna be worth zero after 3 years. But I do agree that after 1 year, it is worth 6,000. Table 8, can you tell me what it's worth after 2 years? Oh wait, not 6,000. 12,000, because it's losing a third. So then 18,000 minus 6,000 is 12,000. But then what's a third of 12,000? Table 8? 4,000 is what it's losing. 12,000 minus 4,000 classes. 8,000 after year 2. So you could do that. You could figure out what a third of this is and then subtract it. Or you could figure out if I'm losing a third, what remains of its value. So if I'm losing a third of its value, what fraction remains of its value? You could just times for each interval by 2/3. And then by another 2/3. What's gonna be my value after the 3rd year, table 9? $5,333, and then since we're talking about money, let's include the 2 decimal spots. What's gonna be the cents? 33 cents. 33 cents. Are you guys seeing now what we're supposed to do actually? Okay, but then notice that it jumps from year 3 to year 6. So table 1, how much will it be worth after 6 years? Okay, let me double check in my calculator. You said 3,555. That would be year 4. But it jumps on the table, your X's. So if I had a year 4, it would be $3,555.56. I don't have it with the long decimal anymore. But that's not year 6. Table 2, do we know year 6? Okay, let's see. Yes. So for year 6, it's $1,580.25. So to go from year 3 to year 6, what math did you do, table 1? Just what you type in your calculator to do that? So you did times 2/3 to get the year 4 value, times 2/3 again to get the year 5, and times 2/3 again to get the year 6, right? Because 3 to 6, there's 3 additional years that is decreasing. How do we shorten repeated multiplication? Exponents. So this is gonna help us make our exponential function. So we're timesing 2/3 each time. So this will go in for the t because I should be able to calculate it no matter what year we're talking about. On your test, it might say find the value in 50 years. Do you want to have to keep multiplying 2/3 all the way up to 50 years? I wouldn't recommend it. But this alone isn't giving me the final answer I need. Like if I plug in year 2, it's not giving me 8,000 when I just do that. So what else do I need to have right here to make it actually give me the right answers? So I gave you part of it. Maybe use what you learned Friday when we talked about exponential growth. It's really similar. Maybe look at your notes, but I'll give you a minute to figure it out in your groups. What else needs to go in for that expression to make it actually give me correct answers, no matter what T is? Don't tell me yet, tell your groups. 1 minute. Okay, who thinks they know it? Candy for whoever volunteers it and gets it right first. So the question is, what else needs to go with this expression to make it actually give me the right answers, no matter what T is? $18,000, good job. So here you can pick from this little bucket of candy I have. But that's it. Think about how you got the other answers from the table. You have to start with your initial amount, times it by 2/3 each time. And however many times you did that, depending on however many years. That's the expression. So listen. There's a spot on your notes right above this that says exponential decay formula. Let's fill that out, because that's like the main point of this lesson. And this is similar to growth. So one of the equations you can use for both growth and decay. Decay means what? What's happening to these numbers as time goes on? Increasing or decreasing? So decay would be for when it decreases each time. You can use that formula, that's really general. Or you could use this other one that maybe can help you figure out the common factor by doing these subtraction. Either one works as long as you get to the right answer at the end of the day. And I'm gonna basically quiz you every day on what these variables represent. So just like how you can tell me for y equals mx plus b and his slope, v is y-intercept, things like that, you need to be able to explain this one to me. So table 8, what does the A stand for? Maybe use this one as a model. This follows this format. A is my. Okay, say what A will come back to, but you guys have to figure out what A is. Maybe look at your notes from Friday. I don't know, but this is gonna be something you guys all need to memorize, so make sure you do. Table 9, what is B for? No, good try. The year was my exponent. So the X would be like your input, the Y would be your output. But how can I figure out what these numbers are? Okay, Carissa, say it louder. B is common factor or ratio. They use both words interchangeably. But common factor is what you're multiplying by each time to get to the next one. So what's my common factor from this example? What do we multiply by each time? 2/3. That's my common factor. Table 8, did you find A? No. A is my,
D,
no.
10,000.
So look at this example that we did,
18,000.
which represents my,
T.
no, someone else. Okay, good. You guys all said it a little bit differently, but it all means the same thing. Initial amount, initial value, starting amount. That needs to be in there. If I'm gonna correctly get the certain term in the sequence. So here's that one that's really general. If you preferred, I don't know, the subtracting one, then you can use this one. As long as you get to the right answer at the end of the day, is all I care about. A will still be for your initial amount. And since it's decay, so like if you compare it to the growth one from Friday, for decay, it's gonna be 1 minus, because it's increasing each time. And what does R stand for, table 1? So think about the math we did up here when we did 1 minus something. Hello. Hello. So if it was this situation, it would be 1 minus 1/3.
Oh, would it be that thing?
Yes, kind of. Okay, so I'll just tell you. It's your decay rate as a decimal. So if it says it's decreasing by 10%, you put 0.10 there. If it's decreasing by 1/3, like that example we just did, you could put 0.33. Or you could do 1 minus 1/3, which is 2/3. That's how we got to B. If that makes sense. This is another way to write B. If it tells you what it's losing each interval. Okay, and then table 2, what does the T stand for? Time. Don't overthink it. If you want to point to this one in this formula and also say that it's time, the input is usually time. Anyway, so that would work. Okay, so now you have a formula. So now you don't have to struggle through finding the pattern and things like that. If you can tell me my starting amount, what it's decreasing by each time, or what it's multiplying by each time, and then for how many intervals to your exponent. All right, we just have a couple more. Answer your 3 and 4 on your paper, or 4 and 5 on your paper. For number 3, it just says make the expression, that's this answer. If you want to copy that over again. Have that in our table. But 4 and 5, you're gonna answer, what's the value of v when t is 0? And what does that mean? And then now a different situation, here's the equation, also in this format. What does 10,000 and 4 fifths mean? We'll go over this, I'd say in about 5 minutes, that's a really long time. But when and if you finish early, you can work on your practice, but you're definitely reviewing this in 5 minutes. Any questions? Ready? 1. Number 4, you needed to use the equation. You needed to use the equation to find v when t is 0. Table 6, what'd you get for that? All right, everyone else listen. This is a lot easier than you think. If this is my equation and t is 0, table 6, what will my answer be? I think she's calculating it, so I'm giving her a second. Everyone else, you should be mentally answering this because I could call in your table next. Okay, table 6, I'll help you out a little bit. When we do the math, do I do exponents first or multiplication? Ken does. Exponents, we learned on Friday, anything to the 0 power is what? 1, so then what's 18,000 times 1? That's it. That's all. You could even see it from the table because we already answered that. When t is 0, my output's 18,000. What does that mean? That's my starting value of the car. That's all. Anytime your input is 0, that's your starting amount. That's why it works. Okay, listen, almost done. No one's leaving until we answer this fully. Table 5. In number 5. Okay, stop packing up. You're being too loud. It's taking forever. Table 5. What does a 10,000 represent in number 5? The amount of the car when? Okay. Look at the position that this is in. Compare it to the formula I gave you. Any number that doesn't have the exponent in there is my starting amount. So it's the amount of the car initially, or some variation of that. What does the 4 fifths mean? Table 4. It's our common factor. We're out of time. But that's what it means. This is what I'm multiplying by each time. So technically it's losing a fifth of its value. But the common factor is 4 fifths. We'll practice that more later this week, but those are the answers.